Physical climate risk is the risk of damage or loss to property and assets caused by the increasing impacts of climate change, such as extreme wind, forest fire, and sea level rise. The XDI team have been world leaders in measuring physical climate risk since 2007. To do this, XDI uses a range of modeling approaches, including structural analysis. This uses an engineering approach to calculate the costs of physical climate risk, now and into the future. Structural analysis allows for customization of assets for stress testing and is particularly useful for exploring adaptation. So how does XDI do it? For over a decade, XDI has been building the climate risk engines, our award-winning computational engine that gathers and analyzes data from thousands of sources to assess the physical climate risk to any type of built asset located anywhere in the world. An asset can be as small as a single power pole, or as large and complex as a manufacturing facility. It can be long and linear, like a train line, or spread out over a large area, like an airport. First, XDI builds a synthetic or digital version of the asset to be assessed, called a building archetype. Think of it as a detailed model of a real asset, inclusive of all the elements a real asset would have. To make it easier, XDI has 140 ready-made archetypes, from houses and offices to water pumps and wind turbines. The archetype is then refined by adding any additional specifications known about the real asset, such as year built, height above ground, design thresholds, value, and location. All of this information is entered into the climate risk engines. Next, we place the archetype in a specific location, anywhere in the world. The climate risk engines then gather information specific to that location. Is it in a flood zone? How high above sea level is it? What type of soil is it built on? Are there forests nearby? And so on. The engines also gather long-term data from local weather stations regarding rainfall, temperatures, humidity, and wind speeds. Now that we have an idea of past and current climate conditions at that location, we need to know what future conditions might look like. Data from government research institutions around the world is gathered and used to project how weather extremes will change under different climate scenarios, from now until the end of the century. We use all of this data to calculate the probability of hazards impacting the asset, the ability of the asset to withstand hazard impacts, and the probability that the asset will fail and be damaged. XDI measures a range of climate hazards, with more in development. The final results are expressed in a range of engineering, financial, and human impact metrics to inform decision-making for a resilient future.